Hi, David. I'm making videos with your data just to kind of personalize and be a little bit more efficient in class because two of you are at very different places in terms of your background with quantitative research. So, kind of personalizing this a little bit through video. So I'm looking at the data set that you submitted. Give you all your points here. Make sure that happens. Let's pause this for a sec. Okay, so I've given you your points. I have just some commentary to make on my wonders. So I'm pulling back up your data set. Okay, no. Alright. So we could do a couple of things here. We could certainly look at this. So you've essentially got, you're looking to see if the distributions across this variable are similar to the distributions across this variable. So we could do this much like with ANOVAs and t-tests. You can look at these individually, or you could look at them just a one-way chi-square, which isn't necessarily all that exciting. Your more interesting question, and more interesting questions are always the consequence of more variables. It's just, again, the balance of being having too many things in the model. But at the same time, it's silly. It's kind of like the point you were making about questions, and part of the reason in some of the questions where there's some variables that are limited is just because of trying to illustrate the relevance of the application of certain tests. And with chi-square, you've only got the ability to run a two-way chi-square. You're not gonna keep moving through that beyond two. Just like a t-test is only for two means. Again, the more interesting question usually involves an ANOVA because you've got more values here. So we can do this with chi-square with string data when it's two-way. So I'm going to go ahead and import this data set. I'm going to pause just for a second. I'm going to go over here to SPSS and import your data set. Excel, which I saved in download. Okay, here, open. It's going to ask me which sheet I want, and I want your nominal sheet. Okay, let's get his. Now, a couple of things. If you were just going to run a two-way chi-square with this string data, meaning words and not numbers, so here, right? You'll be fine. If you wanted to run any single chi-square or one-way chi-square, those won't work with string type data. But for now, it's fine. And then I'll show you quickly how you can get to some workarounds when you sometimes have some problems with string data. Okay, so to run a two-way chi-square, it's here in descriptive statistics, partly because it'll give you cross tabs, and again, it doesn't matter which one you call the row or the column. I like to see these in bar charts. That's just me personally. If you click statistics, this is where you can ask for chi-square. You can ask for correlations, but you won't. You'll see the error message that comes up here. All right, and then these are different kinds of. These are different correlational things. These are different options that you have as a consequence of levels of measurements. You also can get the McNeamer test here. Pardon. Okay. Just ask for chi-square here and click continue. Personally, in this cells value, I just like to see some things. This is just me. So I ask for all of this. You don't have to. As it relates to individual categories, this standardized residuals, so you have a sense about residuals, I assume, as a consequence of some regression work. Just thinking about the residuals as leftover variation that's unaccounted for by the model residual. That those values get standardized, much like we would standardize raw scores in a Z situation, to standardize those to a Z score or a T score or some other kind of thing. And the typical benchmark is that any standardized residual on a chi-square with a value greater than 2.0 is essentially a significant predictor or significant contributor rather than predictor, significant contributor to a significant chi-square. I can't tell you that I've learned about that in a stats class. I've never seen that in an article. If you included that in an article, would someone make you take it out? Not necessarily. It just might be that you don't need it. It could be that just seeing the descriptive data, just seeing the individual values within the table tells enough of the story that you don't need another level of inference, another indicator of whether or not we're likely to see this again in your analysis. So I'm just going to leave it out. Okay. All right. And we'll click OK, and we'll see what we see. Okay. This is good. So we're looking at gender by aptitude. This is a two-way chi-square of independence. Basically, is the distribution across genders similar to the distribution across aptitude. So this is just your descriptive kind of statistics here. Number of people. Now, what you're seeing here is you've got a number of situations where you've got less than 5 here. So 6 cells, 60% have an expected count less than 5. So what ends up happening when you have a chi-square situation, it's much like when we talk about sample size with any test. The standard benchmark for whether or not a category has enough instances in it to be placed in the model is 5, right? Where we have this, mechanism to deal with small sample sizes from a non-parametric test. This, when you're looking at nominal data, essentially you're making a decision whether or not the descriptive lens on the data is sufficient, or if you need to go to the next level of inference. And when you've got this many cells with less than 5 instances in it, this is where you sometimes will have a problem. It'll still run the math, right? But it's, when you send this out for review and people say, you have cells with less than 5, right? Or you have, this is not a category that's even meaningful to this model because there's not that many instances in the category. But it will still do the data, but it will still run the analysis for you, but it will give you a bit of an indicator when you have a bit of a problem. So that's what that's indicating to you. And you're not significant. Your differences aren't that significant. And again, I made this comment to Adam that sometimes the picture just kind of might tell your story. So you don't see a big difference. I assume this is high, low, medium, high, medium, low. So I can appreciate the ordering of that. You might want to do something different. But you can see across gender, not a huge difference here in terms of that. You see a little bit more. Where you see the big difference here is in the medium values. So essentially it's a distribution thing. So you do see some gender differentiation. Now, what this might mean for you is that, okay, instead of looking at the score of aptitude categorically, if you look at it from more of an interval level situation, what was the actual score? I mean, when you put things in a category, you eliminate the variation. It's not as if everybody who's at medium high has the same value, right? So you kind of lose the individual variation. So if you wanted to look at differences across gender, you could look at it if you had aptitude scores and gender. You could simply just look at it as a t-test, independent samples t-test. and see if those were different. And if you had another variable in here, now you're talking about more than two means, and now you're talking about ANOVA being more appropriate. Now, one thing in particular, I do want to show you, if you decided, okay, I want to run, just a one-way chi-square. I want to look to see if there's no difference in terms of gender. If you think those are, if for some reason you just wanted to look at just one variable, if you go up here to analyze and you go to non-parametrics and you go to legacy dialogues and you click chi-square, it's going to say, oops, you can't do that. And it's all because of this variable right here being a string variable. So I've had this happen to me in my life. So one thing that I will just get in the habit of doing, and you see Mixa and Elpis, Pete in all of his videos has asked folks to do this. Or he just demonstrates it. He hasn't necessarily asked or suggested it. He just, everything is... I'm going to do this with gender just because there's only 2 levels and it'll be easier to illustrate. But I'm going to put... I just use the word code. That's just my habit. You can certainly do something different, but I'll show you. This is where you use this value labels option. So we're going to say that 1 are female and 2 are male. And you don't have to use 1 and 2. You can use 99 and 3. Quantitatively, those don't matter. Okay. So then you go back over here, out of variable view into data view, and you've got this gender code variable. So you're looking here at gender, and you want these to match. So you want male. So you can click in this box. Make sure value labels button is on. Click in here, and you'll get a drop down option. Male. Okay. Female. So I'll pause this. So you saw that it was filling this in, where you can click in this drop down box and you can just click on the ones you want. It'll also recognize the first letter, so I'm literally just looking in this column, male, and I'm hitting just the first letters and hitting return. F return. I'm being very careful. And I will say the danger with string variables and importing them into SPSS, especially when you write them all out, which you didn't do, which is good, is you will sometimes, it's case sensitive. So if you capitalize in one place and not in another, it would call it a different category. So it's just finicky in that regard. Female, male, 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 female. I'm going to stop because your video doesn't need to be longer. So I've got them all in, and then what you'll notice, I have value labels turned on. I could turn those off, and now you'll see them categorically. You'll see them numerically. If you wanted, then you could go over here, change this to nominal, and you could say, you could delete this value, this column right here. When you have it in a string, it can only function that way, right? You can only see it that way, and then you can just change this to... And it's really finicky. I don't know why. There it goes. It really is cranky. Alright. Then this way you have all the information you need, but you can see it this way or this way. So just an option. And now if you wanted to go up here and run a one-way chi-square, if for some reason you just wanted to see that just to make a point, you could totally do that. Values equal, click this over here. Okay, if you wanted any of these pieces of information, you can. And there's your one-way chi-square. Not significant across gender. There's your residual value, right? Residual. This minus this, right? This minus this. Residual. The variation. The difference between. So, okay. All right. Hope that helps chi-square be set in your head. See you.